a look at the 2018 AP Calculus exam, and we're going to go on a ride. Now, I remember teaching in a very small town in Nevada years ago. We took our kids to Salt Lake City, and they got a really good rise out of this about an escalator. I mean, that's all they want to do, just ride an escalator all day long. So this question always brings back that memory for me. So let's take a look here. People are entering a line for an escalator. So we're getting in line for an escalator. How exciting is that? And they give us these two rates. Just give us this rate. So remember, this is a rate. So which means this is, for us, it means that's a derivative. And between 0 and 300 seconds, this is the rate at which people are entering the line. And after 300 seconds, oh, look, nobody is getting in line anymore. So RT is measured in people per second, and T is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 feet per second. So in other words, this here is the rate going on the escalator. And now they're telling us the rate at which we leave the escalator. The rate that we leave the escalator. There are 20 people in line at time t equals 0. It's like a Disney ride, huh? People saying, I can't wait for the escalator to go. Oh, we could take the stairs. All right. So first question says, how many people enter the line during the time between 0 and 300? Well, that's a very simple just integral. I want to know how many people enter the line. So this is just an integral. We integrate the rate. So we integrate r of t dt from 0 to 300. Now, this is a calculator question. Please look at that equation right there. They don't expect you to integrate this by hand. But I do like to do the following, though. I always like to check my units to make sure. If I want to know how many people, we should get people. Well, r of t we know is measured. R of t we know is measured in people per second. dt is measured in seconds. Those cancel out. So whatever my answer is, the unit is going to be people. And if we type this equation into our calculator, we wind up with 270 people right there. Very quick, very easy question to answer. Part A is, and this one right here is worth 2 points. You get 1 point for your integral, 1 point for your answer. All right, so let's go and take a look at question B. Now the question B is an FTC problem. It says during the time interval from 0 to 300, there are always people in line at the escalator. I mean, it's like a Disney ride, right? How many people are in line at t equals 300? This is your FTC problem. So from 0 to 300, that's going to be our R of t dt. I want to know how many people are in line at the beginning. Now for part A, we were asked how many people entered the line for those 300 seconds. So there are 270 people that entered the line during that time frame. We want to know how many were there at 300 seconds for part B. Now, but to do this, we do have a little bit of change right here, because since this is the people going in, this is the rate going into the escalator. But you got to remember, we also have people leaving the escalator. So it's not quite as simple as it's a normal FTC, because we also have to consider the people leaving. So we're going to subtract. This is the rate going out. And we're told from the beginning here that we are leaving at a constant rate of 0.7 persons per second. So how do I write that? Now that's not an integral. That is just going to be, I guess you could write this as an integral. You could just go 0.7, the rate leaving, dt. Also from 0 to 300 right here. Now, if you don't want to write it this way, you don't have to. You could just write this as 0.7t without the integral as well. And this is going to equal f of 300 minus f of 0. And if we already know this one, the rate going in, we know how much that is. That was 270. minus over here, if we integrate this 0.7, that's going to be 0.7 times 300. Again, that's just FTC. Remember, we got this from part A right here. That's from part A right here. And that's going to equal the value at 300 minus the initial, which they tell us was, what was it, 20 people? And if you solve this, you're going to get at the very end at 300, you're going to wind up with 80 people left in line. So that means at the end of 300 seconds, there are going to be 80 people remaining. Now, this question is worth 2 points. You get 1 point for your answer. So if you just did the FTC, you got the point. But if you remember to put this rate going out, they give you another point. So it's worth 2 points right there. All right, now for part C, now they're saying, okay, the ride's closed, the escalator's closed. I remember my students were very sad when the mall closed because they couldn't ride the escalator anymore. So for time 3, greater 300, when is the first time that there are no people in line? Well, we just have to find out how long. So they're not going to take any more people after 300. So what we have to do is we have to find out how long it will take to clear these 80 people. So for time greater than 300. So what we're going to have to do is we have to find out how long to empty the escalator, plus the 300 seconds originally. The original 300 seconds, since we're starting after 300. So how long does it take? Well, there are 80 people in line. Divide that by the rate at which they're leaving, which is 0.7 people per second. Add 300 seconds. Now, if you notice here, the people cancel out, and what you're going to be left with is seconds. And what you wind up with is, and it's okay to leave it like this too, by the way. You can leave it as 80 over 0.7 plus 300 seconds. Or if you want to, this is okay to leave. Or if you reduce it, you get 414.286 seconds right there. Now this question is not worth much. It's only worth a whopping 1 point right here. All right, normally that's worth 2, but let's take a look at, but they give us part D here as well. So let's take a look at question D. Ready? Part D says between 0 and 300, at what time is the number of people in line at a minimum value? Oh no. To the nearest whole number, find the number of people in line. Well, this is our candidates test. Right here. So what do we need? Well, we need our critical numbers. Now be careful when you get your critical numbers. We want the number of people in line. So we have to consider the rate in minus the rate out. So if we do this, the rate in minus the rate out, the rate in we know is R of t. The rate out minus 0.7, we have to set that equal to 0. Get our critical number here. Now, I've already done this on a calculator. You can verify this. You get the following times. 33.013 and t equals 166.575 seconds. You also need your endpoints. And those, of course, are 0 and 300. So let's see here. So once you get all those values, by the way, you get 2 points for all of that. And now you just do your candidates test. 0. We need the number of people. Okay? Now be careful. Remember, the number of people is the following integral. We have to integrate 0 to t, rate in, r of t, minus 0.7 dt. Now notice I wrote this another way. I could have wrote this as another integral. But remember, this is the same integral that we use for part B. It's basically the same formula that we use from part B right here. So we would go 0, 300, 33.013, 166.575, and you do that integral to type it in. Of course, 0, plug in 0, you're just going to get 20 We know how many people are already in there at the beginning. If you do the 33.013, you get 3.803. If you type in the 166, what you get if you type in the 166, you actually get this is a maximum value right there, so that's not going to work for us. And for 300, you get 80. So where does the minimum value occur? Well, yeah, right there. There's a minimum number. So we can say that the absolute minimum occurs at t equals 33.013 seconds. Now they do want the number of people, the nearest whole number, with how many people are in there? Well, it's 3.8, so that rounds up to 4 people. And this right here is worth 2 points. 1 point for the time, 1 point for your answer. All right, so take a look at this one. This is a really good question right here. Again, you're going to see an FTC problem on the AP. And this is a really good one because it has that rate in and that rate out. So take a look at that, okay? All right, let's see. And join us for question number 2 in a few moments.